Hi class, this is Mr. Morris. I wanted to go through a short set of notes over endothermic and exothermic changes with you. This is normally covered in the energy unit in pre-AP chemistry, but depending on how your spring worked out last year, you may not have really gotten this topic covered. So we need to go ahead and lay this foundation before diving into notes that rely on your knowledge of energy and energy changes as they relate to endothermic and exothermic processes. So this is really important for the next couple sets of notes. Make sure you follow along and let me know if you have questions about it. We're going to talk about the difference between endothermic and exothermic processes. Everything in the first column is endothermic. Everything in the second column is related to exothermic. So heat is, in the case of endothermic changes, heat is absorbed by the system. When I talk about the system, that means whatever it is that we're focusing on. Generally, we're talking about a physical or a chemical change, especially in chemistry. A lot of times we're talking about a chemical reaction. So if it's involved in the chemical reaction, if it's part of the chemical reaction, so actually written in the equation, that's part of the system. Everything else is actually what we would call the surroundings. So even if we're talking about something that is reacting in aqueous solution, if it's not actually one of the reactants, so it's just the water that the reactants are dissolved in, it's not part of the system. That would be part of the surroundings. So the water in your beaker is part of the surroundings, but the chemical reaction that takes place, the elements and compounds that are actually reacting, are the only parts we refer to as the system. It gets kind of important in a little bit. But just be aware, in an endothermic process, the system or the chemical reaction or physical change that's taking place involves absorbing heat. If we're talking about an exothermic process, heat is released by the system. And in a chemical equation, so if we're looking at the representation of the chemical equation for an endothermic process, we have to put heat into it because it's absorbing it. That's an endothermic process. So we would write this on the reactant side. Heat or energy goes on the reactant side in an endothermic process because you have to put heat in to make it happen. Heat is absorbed by the system. That also means that the change in heat or energy, which is represented by this letter Q, is positive. Okay, so our change in heat or energy, Q, is positive for an endothermic process. Another thing that we use sometimes is delta H, and you're going to see that a lot in AP chemistry. It's called enthalpy, and I'm not going to talk about the differences between enthalpy and heat right now, but just be aware of what they are. They're very similar. Your change in heat or energy, or your change in enthalpy for the system will be positive if we're talking about an endothermic process because it is absorbing that heat. If we're talking about an exothermic process in a chemical equation, we're going to write heat on the product side because it is giving it off. It's producing heat. The system itself gives heat away. It's producing it. It's making it. So it would be a product. And our change in heat or energy is negative, as well as our heat or enthalpy, delta H, that's also going to be negative. Negative means it is releasing heat. So if it is absorbing heat, going back to our endothermic process, if the system is absorbing heat, it's getting it from the surroundings. So the surroundings give heat to the system. The system is absorbing the heat from the surroundings, therefore the surroundings will become colder. In an exothermic process, it's releasing heat, and where does that heat go? It goes to the surroundings. So the surroundings will become hotter. or you could say warmer. Got a couple examples that we could write down. A chemical reaction that you might think of as an endothermic process would be the reaction that takes place in a chemical cold pack. A physical process that you need to be aware of that's endothermic, that's anything that it requires energy in order to change. In order for this to happen, it's absorbing the energy. Think about melting. That sounds a little odd at first maybe, but think about putting an ice cube in your hand. If the ice cube is melting, it's absorbing heat from your hand, so your hand feels cold, and the ice cube itself melts. It changes into liquid. So melting is endothermic. Some examples: a chemical reaction would be like a chemical hot pack. Like Hot Hands is one of the brands, I think. There's several different brands of these that you can take skiing with you, and you rub the pack together and it gets really warm and warms your hands up. So a hand warmer. Any combustion or burning, those are exothermic processes. Also freezing. Freezing is the opposite of melting, of course, and in order to go from a liquid state of matter to the solid state of matter, it has to release the heat to the surroundings so that it can solidify. All right, practice. Take just a moment. I'm going to pause for a moment, pause the video, and try to answer these questions. Okay, I'm going to go ahead and get started with them. The first question, we're asked if these are exothermic or endothermic changes. And the first one you kind of have to think about, a nuclear reactor. What's the purpose of a nuclear reactor? It is to produce energy. It's to produce energy or electricity for an area. So we wouldn't even have a nuclear reactor if it wasn't giving energy off. So it is producing, making energy. That makes it an exothermic process. It's exothermic. A candle burning, it's giving off light and a little bit of heat, so that is also exothermic. Sweat evaporating from your skin, it has to absorb the heat from your skin in order to evaporate, so that makes this endothermic. Melting ice cubes, again melting, it's absorbing heat in order to do the melting, so that would be endothermic. Breaking a chemical bond. It takes energy to break a chemical bond because that is an attractive force in a chemical bond. You have to put energy in to pull them apart. So that is an endothermic process. And forming a chemical bond is the opposite. A chemical bond forms naturally. Think about magnets. If you get magnets close to each other, they just snap together, and there's that loud clapping sound that they would make. Okay, when they snap together, that's a release of energy. So when a chemical bond is formed, it releases energy. So that is exothermic. Removing an electron. So an electron is attracted to the nucleus of an atom. In order to take it away from the nucleus, you have to put energy in to make that happen. So that makes this endothermic. It's very important that you get these last 3 points. And by the way, you could also think if an atom gains an electron, it would be the opposite. That would be exothermic. If you want to jot that down, it might not be a bad idea. Gaining electrons is exothermic. These are probably the most important parts of these notes as far as examples for you to make sure you understand as we move into the next couple sets of notes that we do. Keep these in mind. It's important to note that energy is absorbed when a bond is broken. It has to be absorbed for a bond to be broken, and energy is released when a bond is formed. That's it for our endothermic and exothermic review. Keep these in mind as you go on to the next notes talking about covalent bonding.